Hello and welcome to another exam paper walkthrough. We're continuing with the series for the GCSE Maths June 24 papers. These are practice papers or preparation or predicted if you want to call them that. And this is for the 2F and this is based around the good chance topics. So this is a copy of the paper. In the description to this video you will find a link to a Google Drive where all of 4 of my papers are available. The higher and the foundation, the very likely and the good chance papers. These are the topics that are taken from the key topics as written by First Class Maths. He's also produced some excellent practice papers himself, so please check those out for some additional revision. If you find this video useful and you want notifications of when my other videos become available, please do subscribe if you like. I am planning to put out a Sunday night revision paper for the foundation, so you might want to subscribe and get a copy of that as soon as it becomes live. Okay, so this is the paper. I would definitely recommend download a copy of it to do either beforehand or alongside the video. I hope you find it nice and easy to access. There's some basic instructions. Obviously, also at the end of this paper, there's a full breakdown of the full revision list from First Class Maths, along with the breakdown of this paper. It's 112 questions. And we shall crack on. So question 1, write 0.37 as a fraction. So for this one, this is in effect 3700s. So I'm going to write it as 3700s. And then we simplify the fraction if we can. It doesn't really tell us to, but in this case we can't anyway. So 37 out of 100. Okay, question 2. Here are 4 fractions. Write these fractions in order of size, starting with the smallest. So if this is a non-calculated question, what I would do is I would arrange, I'll put them all over the same denominator. This is a calculator paper though, so I would take the shortcut of just doing them as divisions on my calculator. I got my calculator bigger than I wanted to. Let me just sort that out. Okay, so you can do them as just divisions. So for example, 2 divided by 5 is going to give us 0.4. So convert them all into decimals first of all, because decimals are much easier to order than fractions if we don't have them in the same format, so the same denominators. 0.5, I'm sure you're happy with me doing that one with that calculator. And 0.46. Reoccurring. The reoccurring is important. They have a habit of throwing so 36 over 100 would be 0.36, and then it looks like these are the same size as this one, but this one would be larger because of the reoccurring. So in size order, then starting with the smallest, we are looking at 11 over 30, followed by 2/5, followed by 7/15, and then finally we've got 1/2. Okay, question 3. Work out the value of t when v is equal to 2. I'm just trying to resize my page slightly. I tend to just write down what I'm going to substitute in, and I would, if it was a -2, I'd put that in brackets. And then you can just go to your calculator. If you don't feel you need that though, 4 times 2 is 8, plus 2 would give me 10. And it's +3, not +2. Always check that final scan just to check that you've fully clocked what you were asked to do. Make v the subject of this formula. So this is a bit like solving equations. I want to -3 from both sides as my first step. So t minus 3 is equal to 4 lots of v. I want 1 lot, so I'm going to divide both sides by 4. And then I'm just going to write it here as v is equal to, so v on the left, t minus 3 divided by 4. Okay, question 4 then. This is part of a bus timetable between Bury and Manchester. How many minutes should the 8:25 bus take to go from Bury to Manchester? So the 8:25 starts here and ends here. I'm going to use the time function on my calculator just because, well, to be fair, I'll show you the time function on your calculator, although I'm sure you can work that out. We've got 35 plus 5, 40 minutes. But if you're unsure and you want to just spot how to use the time function on your calculator. 9 hours and 5 minutes, and I want to subtract from it 8 hours and 25 minutes. I type it in like this. Time button is this button here. It looks like a dot, comma, comma, comma. So 9 hours and 5 minutes minus the time of 8 hours and 25 minutes. And I think he said it's 40 minutes. So that's 0 hours, 40 minutes and 0 seconds. So 40 minutes. Daniel goes from W to M by bus. W to M by bus. Daniel takes 17 minutes to get from his house to the bus stop in W. It takes 15 minutes to get from his bus stop at Manchester to work. He has to get to work for 10 AM. He leaves the house at 8:45. Does he get to work by 10 AM? Okay, so we'll see if we need the time function or not. So I'm going to do 8 hours and 45 minutes plus the time it takes him to travel to the bus stop, which would be 17 minutes. Which would be 0 hours and 17 minutes, 0 hours and 17 minutes, which would take me to 9 hours and 2 minutes. From there, the bus that he can catch is going to be the 9:04 bus, which I don't need the time for this, but that will get to Manchester at 9:35. Just double checking I've read that right. 9:35, yep. And then it takes him 15 minutes to get from the bus stop to work. So I want to add on 0 hours and 15 minutes, which will take me to 9 hours and 50 minutes. So yes, he will be 10 minutes early. So question 5, Davos is a cleaner. The table shows information about the time it will take him to clean each of 4 rooms in his house. Davos wants to clean all 4 rooms in one day. He will take a break of 45 minutes. Davos is going to start cleaning at 9 AM. Will he finish by 4 PM? So let's just work out his time. So I want to just trying to work out the best format for me to do this in. So I can literally do this as 9 hours and 0 minutes plus 1 hour and 40 minutes plus, I think I can do it as plus 1.5 hours and 0 minutes plus 0 hours and 45 minutes, 0 hours and 45 minutes plus the 75-minute break, so 0 hours and 75 minutes. And that'll tell me the time that he finishes. So 9 o'clock is the time. And then to that, I want to add 1 hour and 40 minutes. To that, I want to add 1.5 hours and 0 minutes. And to that, I want to add 0 hours and 45 minutes. And to that, I want to add 0 hours and 75 minutes for his break. That tells us that he will finish. I feel like I've missed a time out there. I missed the kitchen. Missed the first one. So I should have done this. So to that time, I need to add on a further 2 hours and 0 minutes. But it was too early, so plus 2 hours and 0 minutes. So that tells us that he would finish at 16 hours and 10 minutes. So will he finish cleaning at 4 o'clock? No. He will finish at 4:10 PM. Just put it back in the format that the question is working in, so on a 12-hour clock. Okay, question 6. Here is a probability scale. Write down the letter of an event that is certain. So probability is D. Write down a letter of an event that is unlikely. So unlikely doesn't mean impossible. That would be A. Unlikely would be B. There are 12 bags in a counter. 3 of them are red. 1 counter is blue. 2 counters are yellow. The rest of the counters are green. Colin takes a counter at random from the bag. So the probability that the counter is yellow or green is 2/3. Well, I'm going to do this dead simple. I'm going to say that that's going to be 1 minus the probability of them being red or blue. So that's going to be 1 minus, we've got 3 and 1. So we've got 4 out of 12 that are red or blue, which means that we've got 6 out of 12 that are yellow or green, and that would cancel down to by 6, 2/3. No, it wouldn't. Cancel down by 3 would give me. So I've made a mistake there. Let me just correct that. 12/12 minus 4/12 would be 8/12, and then if I cancel down by a factor of 4, that would be 2/3. So that's how I should have done that. Apologies there. Okay, question 7. 72 people did the test. 20 of the 32 adults who did the test passed. 6 of the children who did the test failed them. Did the test failed. Use the information to complete the frequency tree. So Reddit wants to get a feeling for it. Now I'm going to extract the information. So 72 did the test. So 72 would go there. 20 of the 32 adults who did the test failed. So 32 would go there. 20 would go there. And then 6 of the children who did the test failed. That's extracting the information. Then I can start working out my other values. So 32 minus 20 would give me 12. And then 72 minus 32 would be 40, which means that 40, not 46. And then 40 minus 6 would be 34. And then second part, one of the people is picked at random. Find the probability that the person is an adult who failed the test. So one of the person is picked at random. That tells us the denominator is 72. Is an adult who failed the test. That tells us the numerator. Adult who failed the test would be so I've got these two the wrong way around, haven't I? Well, I don't know if you'd spotted that. We're screaming at the video. So adult that failed the test would be 12 out of 72. Don't need to because it doesn't say in its simplest form, but that would definitely simplify to 1/6. Question 8. Daniel bakes 420 cakes. He bakes only vanilla, banana, and lemon cakes and chocolate cakes, so 4. 2/7 of the cakes are vanilla, 35% of the cakes are banana. The ratio of the number to lemon to the number of chocolates is 4 to 5. Work out the number of lemon cakes. Right, so I'm going to put this information into a bit of a ratio table. Not really a table, more of a list. So I've got 2/7 there. I've got 35% there. I haven't got this, but I've got the ratio of these two. I'm going to put that in brackets because that's not related to the others. Work out the number of lemon cakes. So this is the number that I'm trying to work out. So what I'm going to do is I'm going to work out this. So 2/7 times by 35% or times by 0.35 will give us the percentage that has already been covered. Yeah, will give us the, not the percentage, but it will give us the decimal version of what's already been covered. I think it might give me it as a fraction. Yeah, 1/10. So 1/10, that's not right. There we go. I should have added them. Silly mistake there. I'm trying to do a probability. So we've already accounted for 89 out of the 140, which is encouraging. So the fraction that have not been accounted for would be 1 minus that. So this is going to be 51 out of 140. And then we want to times that by 4/9. So 51 out of 140 times by 4/9. Times by 4/9. So that gives me the fraction that are lemon cakes. And if we want the number of lemon cakes, then we need to times that by 420. So times by 420, so we get 68. Not really happy with how that worked out. I thought that sticking with it in terms of fractions would be simpler, but in retrospect, I don't necessarily think it would. So I'm just going to redo this question. Actually, we don't need to. I'm just going to rewind and do that different method just to check. Which I'm always a big fan of. If there's something that you can do more than one way, checking it is always a good method. So if I actually work out the quantities for these two, so if I do 2/7 times by 420, that gives me 120 of vanilla. If I do 35 times by 420, sorry. 0.35, so we've got 147 of those, which means that the total of these must be 420 minus my last answer, so we've got 273 that we need to split in the ratio 4:5. So if I go lemon to chocolate again of 4:5, and I've split in 273 in that ratio, I'm going to divide it by 9 for the 9 parts, so divided by 9, and it looks like I've made a mistake somewhere. Let's just quickly review that. 276, so 420 minus that, 153. So not sure what I did there. 153 divided by 9 gives me a much better answer, so 17, and then 4 times by 17 gives me the 68 again. So similar amount of work into both, to be fair. It didn't take much of a shortcut, leaving it as fractions. Leaving it as fractions. Okay, question 9. Diagram shows a prism with a cross section in the shape of a trapezium. On the centimeter grid below, draw the front elevation and the side elevation of the prism. So from the front, set the scale of 2 centimeters to 1 meter. So that would need to be 4 centimeters. This length here would also need to be 4 centimeters. And this length here would be 1. So I'm going to draw a 4 by 4 by 1. So that's going to be my front. And then my side elevation would be 1 by 2. And I've misdrawn there. I wrote 1, but I've drawn it as 2. 4 by 4 by 1. And then this should be a 1 by 2. And I've just realised I've gone the wrong way on this. Making lots of mistakes this morning. Right. If I'm using a scale of 2 centimetres for every 1 metre, then 2 metres would be 4 centimetres. No, I was right. Shouldn't have doubted myself. Double in them all. Didn't look big enough. So 4 by 4 by 1 and 1 by 2. We've got front and we've got side. And we see this top edge as well. That top edge would be this edge here. So that's going to be my completed diagram. Right, question 12. A farmer has 20 boxes of eggs. There are 6 eggs in each box. Write the ratio of the number of eggs in 2 boxes to the number of eggs, to the total number of eggs. Write the ratio of the number of eggs in 2 boxes the total number of eggs. So in effect, that's going to be a bit of a weird question. Number of eggs in 2 boxes would be 2 times 6. To total number of eggs in all of the boxes would be 20 times 6. So that would just be 1 to 2 to 10, the 2 to 20, which would be 1 to 10. So the 6 is actually irrelevant in this question. Okay, complete table of values. So table of values can use our calculator if we're happy with the function, the table mode. So if I type this in as 0.5 times by x, so 0.5x minus 1 alpha x minus 1 equals, don't need a second function, I want my values to start at minus 2 and I want them to end at 3. I want it to end at 3 and I want steps of 1, so that automatically fills it in, although you don't need the table function for that if you're confident with your so there we go. But if you spot the fact that they're just going to go by 0.5 each time, that will be absolutely fine as well. Draw the graph to represent that. So minus 2, 2 is my first point. I've then got minus 1 and minus 1.5, minus 0, minus 1, 1, 0.5, 2, 0, and then 3.5. Then just join them up with this straight line. Just make that red to match my writing. There we go. And slightly out. Now let me put it exactly where I want it. Okay, so there we go. Have we got any follow-up? Use your graph to find the value of x when y is equal to 0.5. So when y is equal to 0.3, sorry, is this point here. So x would be equal to 0.8. And I've done x and found the value of y. Y is 0.3 is this line here. which is looking like 2.6. Right, question 14. This diagram shows a quadrilateral. AB is equal to AD. That implies that we've got a kite. Show that it is a kite. So the properties of a kite would be that we've got two equal sides. One pair of equal opposite angles. So we've already told that AB is equal to AD. So that's given in the question. So we need to find these two angles. So let's look at the way that I'm going to do that. I'm going to say that that would be equal to 50 degrees. BCD is equal to 50 as it's vertically opposite. The 50-degree angle. I'm then going to say that this angle here, ADC is going to be equal to 180 minus 75. So that's going to be equal to 105. And the reason for that is angles on a line. Angles on a line equal 180 degrees. And then finally, I'm going to say angles in a quadrilateral need to add up to 360. So AB, missed it, ABC is equal to 180 minus 100 plus 50 plus 105, which is equal to, go back to my calculator mode, 180 minus 100 plus 50 plus 105. So that equals, I've typed something in wrong, 360. Gosh. 360. This video is littered with mistakes from me. Do apologise. 105. So must be a kite. So that's one pair of opposite angles that are equal. Okay, question 15. The diagram shows the front elevation, the front elevation and the side elevation of a solid shape drawn on a centimetre grid. On the space below, sketch. Draw a sketch of the solid, give the dimensions of your solid in the sketch. Well, if we think about it, from above we're seeing a circle. From the front we're seeing a rectangle. And from the side we're seeing a rectangle. So the shape that we must have is a cylinder. Showing my dimensions then. So I've got my, we can show the radius or the diameter really. That's going to be 4 centimetres. We also need the height. And the height, let's just check. So 4 would be this part, so the height would be 2, 4, 5 centimetres. And I think that's absolutely fine. I'm going to show the hidden side as well. There we go. Right, question 16. Find as a column vector 2a plus 3 minus 3b. So it's two lots of 3, 4 minus 3 lots of 5 minus 2. So we kind of, in effect, what we do here is really we kind of split our top number and our bottom number separately, but they're both multiplied by this. So my top number is going to become 2 times 3 is 6, minus 15, so that would be minus 9. And my bottom number is going to become 2 times 4 is 8, Minus 3 times by minus 2 is 6, so it's going to be 8 plus 6. I think that's 14. On Saturday, some adults and some children went to the theatre. The ratio of the number of adults to the number of children is 5 to 2. Each person had a seat in the circle or in the stalls. 3/4 of the children had seats in the stalls. 117 of the children had seats in the circle. There are exactly 2,600 seats in the theatre. On Saturday, were there people on more than 60% of the seats? Right, so I'm going to ignore those bits for now. I'm kind of going to put this into a bit of a two-way table, I think, because we've got children, adults, and we've got total. We've got stall, circle, and total. And I might not rely on this. It's just going to help me process the information. Right, the information that I've actually got is 117 children sat in the circle. So children and circle, that's 117. From that, 3/4 of the children were seated in the stall. So that means that this 117 has to represent 1/4. So let me just check. Yeah, so that's 1/4. That means that we must have 3/4 here. So if I times this value by 3, so 117 times by 3 gives me 351. And we're told here that the ratio of the number of adults to children was 5 to 2. And we know that there are, I'll put that in the wrong place, 351 there. So we can say that the total number of children then is going to be that value plus 117. Could have just times it by 4 instead. 468. So 468. So the number of adults then to get from there to there, I'm times it by 232. Let's just double check that though. 468 divided by 2 is 234, and we want to times that by 5. Actually, no, yeah. I'll times it by 7 because that will tell me the total number of people. So we've actually got 1,638 people. 1638. So we want to work out whether that value is bigger or less than 60%. So if I do 1,638 divided by 2,600 times by 100, that will give us the percentage that are filled. So that divided by 2,600 and then times by 100, so 63% is filled. So my answer is yes, 63% is full. Right, question 18. Katie invests £200,000 in a savings account for 4 years. The account pays a compound interest of 1.5% per annum. Calculate the amount of money at the end of the 4 years. So initial investment times by the interest rate as a decimal. I did the 0 by mistake. 1.015 to the power of the number of years. So 200,000. Double check my zeros. I've got one too many. 5 zeros times by 1.015 to the power of 4 gives me £212,272.71, but I'll put it all down. So the amount of interest, just double checking, the amount of interest Katie will have. Calculate the total amount of interest. So we want to minus the initial investment to find the interest. So minus 200,000 So £12,272.7101. So the amount of interest is £12,272.71. Right, 19. Got pentagon. The angle BCD is 2 times the angle ABC. Work out the size of the angle ACD. So let's call that X for now. Then we call that one twice as big, so 2X. So we want the angles in this to equal 180 times by n minus 2. So 180 times by 3. That's 540. So we know that the angle sum then, so I'm going to do 90 plus 115, because that's 90 by the way, plus 125 plus x plus 2x has to equal 540. So let's simplify the number part. So 90 plus 115 plus 125 gives us 330 plus 3x is equal to 540 minus 3, so minus 330 from both sides gives us 3x is equal to 540. I'm just doubting my own maths at the moment. Yeah, minus 330, 210. So divide both sides by 3. We get x is equal to 70. Right, find the size of angle BCD. So that's going to be 2x, so that's going to be 140. Okay then, question 20. Draw an accurate front elevation of the pyramid in the direction of the arrow shown. So I see this bottom edge is 6 centimeters. So I want a 6 centimeter line, 2, 4, 6. And then the height that I would see is the vertical height, not the slope height. So 4 centimeters, so 2, 4. And all sides are equal, so it would be directly above. I encourage you to use a ruler. Right, to work out the surface area of the pyramid. Okay, so if I just kind of imagine the pyramid, the net, very roughly there. Right, I'm going to have a square in the middle. Square in the middle would be a 6 by 6. And then I'm going to have 4 triangles. Half of the base times height. So the base of the triangle would be 6. The height of the triangle would be the slant height, so it would be 5. So that's going to be 36 plus, this now becomes 2 times 30, so 60, so we're looking at 96. And no unit here, so centimeters squared. Okay, question 21. Complete the probability tree. So the probability of taking counter, the green counter is, so green is 0.2 more than the pink. So if I call that x, that would be 0.2 plus x. So these have all got to add up to 1. So currently they add up to 0.05 plus 0.15 plus plus 0.2. So currently they add up to 0.4. So 0.4 plus 2x has to be equal to 1. So 2x has got to be equal to 0.6. So x has got to be equal to 0.3. So that's got to be 0.3 then and 0.5. To checking I've got those the right way round. So there are 18 blue counters. Work out the total number of counters in the bag. It's probability of picking an 8. Well, if the total number of counters times by 0.15 is equal to 18, then the total number of counters must be equal to 18 divided by 0.15. So 18 divided by 0.15 is going to give us a 120. Right, question 22. So we've got, here are 6 graphs. So let's pretend I've not seen what graphs we've got. We've got quadratic. So this is a positive quadratic. So something along the lines of y is equal to ax squared. This is a cubic, so that's in the form y is equal to ax cubed plus bx dot dot dot. This is what's called a negative reciprocal graph. So that would be y is equal to minus a over x. This is a reciprocal graph, so y is equal to a over x. This is a straight line, so y equals mx plus c. And then this is another cubic, but with no b coefficient, so that would just be ax squared cubed. Right, so match the letters. Y is equal to x cubed, that must be graph f. Y is equal to 1 over x, that must be graph d. So f and d. Right. Okay, question 22. This diagram shows 2 squares. Work out the area of the shaded square work out the area of the square shown shaded in the diagram. So to work this out, we've got to work out this length here. To do that, I'm going to use we've got a right angle triangle where we've got a relationship between the 3 sides, so we're using Pythag. So x squared is going to be equal to 3 squared plus 5 squared, which is going to give us 16, which is going to give us 36. Sorry, 34. So we want x, which is going to be equal to the square root of those 2 sides, the square root of 34. And I'm going to leave my answer, it's going to give it me as a third, so, well, root 34. So work out the area of the square shown. So the area is going to be x squared, which we worked out here anyway. So we're looking at 34. So we're looking at 34, and again, we've got no unit mentioned, so centimeters squared. Right, question 25. Here is a number line. Write down the inequality shown on the number line. So we've got minus 3 and we've got 1. Let's make that 3 a little clearer. So x ranges between those 2 values. If we imagine the line is kind of a liquid, it goes into the first one, so it can be equal to the first one. But it can't be equal to the second one. So that's my inequality. Minus 3 is less than or equal to x, which is less than 1. Okay, question 25. The diagram shows the plan of Jason's garden. Interesting shaped garden. A, B, C, O, A, B, C, O, and D, E, F, O are rectangles. C, D, O is a right angle triangle. And AFO is the sector of a circle with a center of O and an angle of AOF is equal to 90 degrees. So all that information is given in the diagram. Jason is going to cover the garden with grass seeds. Each bag of grass seeds covers 14 meters squared of garden. Each bag of grass seeds costs £10.95. How much will it cost Jason to buy all the bags of seeds that he needs? Right, so I'm going to work these areas out individually, so I'll kind of show it on the diagram. The area of that one will be 11 times 7, the area of that one would be 9 times 7, the area of this one would be a half of 11 times 9. Let's just check 11 and 9, and then the half, this is going to be a quarter of pi times r squared, so pi times 7 squared. So I need to add all those together. So 9 times 7 plus 11 times 7 plus 0.5 times 11 times 9 plus 0.25. Could type it in as a quarter, but that just says messing around with the fraction button. Pi times by 7 squared. So my total area is going to be equal to my rubber's not working. There we go. 2044.983245. So the number of bags of seeds that he needs are going to be that divided by 14. So if I do that divided by 14, gives me the value of 146.072 ... and this just seems too large, and I've just gone back and looked at my calculation, and what I've done is 0.5 times by 11 times by 9. You might have spotted this as I did it here. This should have been a plus, and I've put it in as a multiply, so that sounds much more likely. So always good to double check our calculations. So we were looking at 227.98451. When I divide that by 14, I would get 16.2846 ... So I would need 17 bags. So my actual answer to the calculation is going to be 17 times by 10.95. That's going to give me 17 times by 10.95. So that's going to give me total cost of £186.15. £186.15. There we go. Right, question 26. Lorena gets a train at the same time every morning to go to work. She gets a train at the same time each evening to come home. Probability tree diagram shows the probability of each train arriving late. Complete the probability tree diagram. Well, the probability tree diagram, the combination of these two needs to add up to 1, so this has got to be 0.87. This one's going to have to be 0.94, and this one's got to be 0.94. For a day that Lorraine goes to work, work out the probability that the train to work and the train home will both arrive late. So both arrive late would be this branch here, which is going to be 0.13 multiplied by 0.06 or 0. 0.13 times by 0.06 gives me 0.0078. Okay. Question 27. We've got a triangle. I'm given information. Work out the size of EAB. So EAB. So we want this angle here. Okay, you must give a reason for each stage of your working. So I'm going to do it, if I call this X for now, I'm going to call this Y. And I'm going to do it like this. I'm going to say that we've got a trapezium here. So these two angles, because they're parallel, they're co-interior angles or supplementary angles. So I'm going to say that BCD, even though I called it Y, I'll give it the proper notation, is going to be equal to 180 minus 148. So it's got to be equal to 32. And the reason for that is that it is supplementary or co-interior. Whichever version you want to use is absolutely fine. Co-interior. interior angle to EBC. And then based on that, I'm going to say the angles in a triangle add up to 180. So EAB is going to be equal to 180 minus 63 plus 32. So that's going to be equal to 180 minus 63 plus 32. Just double checking my angles there. So it's going to be 85. My reason for that is angles in a triangle equal 180 degrees. Okay then, question 28. In a sale, the normal price of a book is reduced by 30%. The sale price of the book is £2.80. So if it's been reduced by 30%, it's going to be a multiplier of 0.7. So the original price times by 0.7 would be equal to 2.8. So the original price would be 2.8 divided by the multiplier divided by 0.7. So 2.8 divided by 0.7 is going to be 4. Right, question 29. Solve the simultaneous equation, and we've got neither of them have got the same coefficient. So this one's got an x coefficient of 5 and 1. This one's got a y coefficient of 1 and -3. And I need them to have the same kind of size. Whether they be pluses or minuses is irrelevant at this first step. So what I'm going to do is I'm going to call this equation 1 and this equation 2, and I'm going to say I'm going to multiply equation 2 by 3. Equation 1 by 3. That would give me 15x plus 3y is equal to 63. And I'll call that equation 3. I'm then going to say equation 3 plus equation 2 is going to be equal to 15x plus x is 16x, minus 3y plus 3y is 0, and then 9 plus 63 is going to be 72. So x is going to be equal to 72 divided by 72 divided by 16. So 4.5. I'm then going to sub my value for x into one of my initial equations, whichever one works best for me, which will probably be equation 1. Save avoiding any negative numbers. So 5 times by £4.50 plus y is equal to 21. So times that by 5 gives me 45 over 2. And then, so I'm going to say y is going to be equal to 21 minus that. So 21 minus my last answer. Doesn't make sense. It does. For some reason, I was still thinking it was book prices. So we're looking at minus 1.5. So x is equal to 4.5 and y is equal to minus 1.5. We can always do a check if we're not confident with that. So check with the equation that we didn't use for the substitution. So check with equation 2. And this doesn't need to be anything big. 4 times by 4.5 is 4.5. Then 3 times by minus 1.5 would be plus negative times the negative, 4.5, and that does equal 9. So that gives us the confidence that we are right there. Okay then, question 30. So we've got trapezium, work out the size of angle CDA. So I'm after this angle here. That's a Greek letter theta. Just stands for a missing angle. We tend to use theta for a missing angle, x for a missing side. Giving your answer correct to one decimal place. Right, so I know that the height, so if I split this into a right angle triangle here, I know that the height of this is 6 because it's going to be consistent with this height. What I don't know though is this length here. I know that it's going to be 24 minus 10, but I need to work out this length here for me to be fully able to work that out. So let's work that out first of all. X squared is going to be equal to, we've got Pythagoras again because it's 3 sides. And we're trying to work out a shorter side this time, so it's 7.5 squared minus 6 squared, which would give me 7.5 squared minus 6 squared, square root of 81 over 4. So the square root of 81 over 4, well, the square root of 81 is 9, the square root of 4 is 2, so it's going to be 4.5. So I'm then going to work out this length here, which I'll call y for now, just for my notes. So y is going to be equal to 24 minus 10 minus 9 over 2. So that's going to be 24 minus 10 minus my last answer. So that's clearly not right. There we go, I didn't do that on a calculator, did I? So minus 4.5. So we're looking at 9.5 for that length there. Right, so we've got that length, we've got that length. Now we've got, let's change pen colour for this. So this is the opposite side, this is the adjacent side, so we're using the tan ratio. So tan is equal to opposite over adjacent. And it is tan that we're trying to work out, so theta is going to be equal to tan to the minus 1 of the opposite side over the adjacent side. So shift tan, and then I want to type it in as a fraction, 6 over my last answer. Gives me 32.2756 ... more accurate than needed, and then we round. So 32.3. Question 31. The accurately drawn map shows the position of 3 points A, B, and C in a field. 1 centimeter represents 150 meters. Parveen walks in a straight line from A to B, and then from B to C. Susan walks in a straight line from A to C. Parveen walks more meters than Susan. How many more? Right, so before I bring my ruler in, because I've got to do that in kind of a different steps for this, what I'm going to do is I'm just going to mark on the straight lines that I need for this question. Right, so A to B, and then I want another one that's going to represent B to C, and then I want a final one which is going to represent A to C. And then I need to measure the length of those 3 lines. So I'm going to bring in my ruler. Right, I'm just going to adjust my page slightly. Okay, so I'm going to measure the length of each of these lines. So the first line and this is slightly awkward for me, but the first line I measure as being 5 centimeters. So A to B is equal to 5 centimeters. Then I want B to C. And I make that 4 centimeters. So B to C is equal to 4 centimeters. And then I need A to C. Right, and I make A to C 7 centimeters. So A to C is equal to 7 centimeters. Right, so This is the journey one, so the total. So I could convert all of these into meters. So I could convert 3 times into meters and then subtract the sum of this from the sum of this. But what I'm going to do is I'm going to stay in centimeters because that will mean I only need to do one. So total journey there would be 9 centimeters. So 9 centimeters minus 7 centimeters would be 2 centimeters. And then I can do my conversion. If 1 centimeter represents 150 meters, 2 centimeters is going to represent 300 meters. So 300. And there'll be a range of values acceptable for that. Let's just have a look. Mark scheme says answers in the range of 210 to 390. Wow, there's big range there. But there we go. So part B, find by measurement the bearing of A from C. So I'm going from C. Okay, so I've already got my north line measured on. Just going to get rid of my ruler and grab my protractor. Okay, so here's my protractor. I've only got a 180-degree protractor. Bearings are measured in as 3 figures from the north. Let me just, was it A from C? Yeah, it was A from C. So I actually want this angle here. I can't measure that with my protractor, so what I'm going to measure is this angle here. So I'm going to take my protractor, I'm going to spin it around to vertical. That looks vertical. Place it on the center at C, from C. Always tells you where you're measuring from. Right. Let's just put that a bit more accurately. A little bit better. Okay, so I'm measuring that angle there. If I'm going from the inside numbers, so I make that just over 70. So I'm going to call that 71 because it is just over. You can see on the scale here, 71 degrees. So my actual angle is going to be 360 minus 71. So 360 minus 71 is going to give me 289. So 289 I've gone for. And again, I'll check the mark scheme for that. So the mark scheme says answers in the range of 286 up to 290. So we're within the range. Okay, and that brings us to the end of the paper. So as mentioned at the start of the video, all the questions on this are based around, this is first class maths key topics for the foundation for paper 3. And this paper has been based around the good chance. So there is a separate video called the very likely paper. Please do check that out if you haven't already, which are the 5-star and the 4-star. This is just based around the 3-star questions. Hope you found that useful. Once I was given this, I've then gone and I've just focused on these questions. I've used Edexcel's enhanced skills map to generate the paper. So pick questions that matched the skills tested, matched the topic list. I then arranged the paper by mean percentage, mean difficulty. So the paper was designed to try and build in its difficulty level. Then produced the paper from that. Before I sign off, I will just bring up the skills map. Okay, so this is the document. The only other thing that I wanted to mention was just, in theory, this paper was originally out of 91 marks, but the total for the paper has gone up slightly because, for example, for the third question, substitute values into the formula, but I chose this question, which was substitution and rearranging, which is two of the key skills, so it made sense to include them both. So actually the maximum mark for your paper, the one that you've just done, is slightly higher than this. Based on those 91 marks, the kind of the grade boundaries for that were number of marks was 57 for a 5, 38 for a 4, 25 for a 3, 15 for a, 26 and 16, and 9 for a 1. So again, I hope you found that paper useful. Please do check out the other papers. The very good chance, the very likely paper, particularly for the foundation tier, will be exceptionally useful. I'll also be producing a Sunday night paper for the foundation tier, which is just kind of a slightly more easier version of the very likely paper. Just to give a bit more practice and a bit of confidence boost before the exam. Make sure you subscribe to the channel and you'll get a live update when that video comes out. Other than that, thank you very much for listening. Please do continue with your revision. Good luck with your exam. I hope you get everything that you've worked for, and I will hopefully see you soon.